So we have a fulcrum here. Let's start from myself. In the last week, I was trying to benchmark Crimson OSD and to try to compare its read performance with that of classic OSD. And it turns out per my test, the performance is roughly the same, but the reader has more insight regarding to the test result. And also was reviewing Yinxin's PR adding the V2 messenger support to Crimson Messenger. And that, I think that's me. Trimi, how's it going?
I almost finished my other tasks, and then I can continue on SeaStor Crimson. So please discuss offline what tasks can I continue going on.
Trimi, I think probably you can grab a task in the project page.
Project
I'm posting
page?
in the chat window.
Okay. Yeah, I will take a look and tell you what I will go on.
Yes, and update the team with your interest.
Yeah, thank you.
Redek, how's it on the side?
Hello, I was benchmarking Crimson using smaller chunks. First of all, I was able to reproduce your results using bigger chunks for megabytes segments in the Rados bench test. For big chunks, well, we are slower, significantly slower. But this is not the most important case for the comparison. I guess we are focused mostly on small 4K random reads, and there, well, we are pretty good. In short, those results are very preliminary. They need to be confirmed. They must be repeated by someone else. But on Inserta 07, I'm getting around 50% more Crimson for 60% of CPU in comparison to classical OSD. I posted a link to the gist with snippets and some profiling I made for Crimson OSD. It's still work in progress. At the moment, I'm focused on the TMEM, Intel's TMEM methodology, TMEM analysis to get more insight what is our bottleneck. But from the very rough profiling, it seems that we have low-hanging fruits like PG wait for active. It's mostly I've taken your one-liner for enforcing the PG state to active, and well, it looks we are doing a lot of logging there, which is just expensive. More than.
What do you mean by flopping there?
Sorry.
What do you mean by the flopping? Why it is expensive?
Do you mean wait for active? Mostly because of logging.
Flogging, okay. I just don't get this part because the wait for active is a very quick check, right? And if we do the cheat, it will just return right away.
Yep. We are fulfilling. We are returning now. there now.
Hi, Redog. What tool do you use to profile?
Used perf tools, standard perf tools. Perf stat and perf record, perf report.
Okay.
But if you want to
Dan,
verify,
I cannot hear you. Seems you're trying to talk. Okay.
if you want to verify, I would advise to build the project with frame pointer support. I was trying to profiling with Dwarf or last branch record of PMU, but well, the stacks are so big that this doesn't work really. I had to rebuild entire project using with the frame pointer enabled.
Can you hear me now?
But well, there is a snippet
Yes.
with the comments necessary to do that.
Can you guys hear me? Maybe?
I can.
Yes, perfectly.
Thanks. Sorry. I have a microphone that doesn't work well. Okay, so you're saying wait for active is burning a lot of CPU? How you have logging disabled, right? I'm wondering about PG state string specifically. Is it calling that even when logging is disabled?
Well, we have. I haven't tuned any logging configurables. It was Crimson was printing an std out. I redirected its output to devnull, but still there was around 6.5 of percent of cycles spent there.
I'm asking because if I understand the magic correctly that SeaStor uses for its logging, so for classic OSD, it avoids like evaluating the OStream operator whatever sequence in the case where logging is disabled with a macro, right? It's got a little if block sort of compiled in there. For SeaStor though, I'm worried about this PG state string call. I suspect that that's getting evaluated even when logging is disabled, right?
Could be.
Ordinarily, SeaStor bypasses that logic by instead of doing pre-processing and passing it a string, you pass it a thing with operator stream defined on it, which it can either invoke or not. So that, because obviously the reference passing is free, but the OStream operator call is not. So for PG state string, I suspect we need to rephrase that into something else. Or just comment it out. Like if we think it's the logging that's causing trouble for performance reasons, that would probably be even more expedient.
We can print the unit debug,
yeah,
or just remove it.
Sure, but guys, it's very early. These things are extremely early.
Okay, fair enough.
Logging is in long term. Sure, we need to fix that, but in short term, I would prefer to focus more on verifying whether we are actually doing the reads correctly. Just to ensure we don't have a bug that causes huge performance improvement at the cost of not doing the real job. At the cost of avoiding doing the real job. But well, from the profile, it looks that we really spent some time in the SeaStor. The share of this is quite small, but in case of classical OSD, well, it's not big. Just couple of percent in classical OSD is being spent, is being burnt on Memstar. Most of cycles are just burnt for orchestration, not for real job.
Well, that's what concerns me about this whole testing process. That orchestration layer that classic OSD is doing, spending most of its cycles on, we haven't implemented yet, SeaStor in Crimson, right? It's not that we're doing it faster, it's that we're not doing it at all.
No, we're not doing them.
Yeah. Which is not to say that this isn't a useful test, it's just pointing out. It's testing mainly the messenger implementation, which is valuable.
But, well, not entirely sure. We know
what is
that
there other than the messenger implementation and SeaStor?
wait a moment. We have messenger, we have the read path, we have memstor.
Not
And
really. So classic OSD burns a bunch of like CPUs checking stuff like, is this object missing? Is this object recovered? Is this object recovering? Do I need to do cache crap to it? Like all that stuff, right? None of that's implemented in Crimson yet, though.
Okay.
Like the read path is essentially just a direct call right into SeaStor, if I'm reading this correctly.
Yeah, and also do some preliminary test regarding to against the object import.
Okay.
And
That's a good
to
point.
find
It
the
does pull out and
snapshot.
decode the object. That's a fair point. True.
But Sam, I don't think your opinion holds, because in the general case, if a reader is successful, it won't be held up by
yeah, it won't be held up, but it is going to burn CPUs on the checks. That's actually something we've seen in profiles in the past. Like the sheer amount of code that it churns through to conclude that it has nothing to do is like staggering.
Even they just try to find
Like
the
it has
object ID
nothing to
in the
do,
map.
but it has to check a bunch of stuff to confirm that for no good reason.
Okay.
Which is exactly what we need to avoid doing in Crimson. I'm just pointing out that we haven't actually written the code that does that yet. Not that that's a bad thing of the test. I'm just kind of pointing out that there isn't really anything in between the messenger and cyan to run right now.
Well, in that case, I guess we will need to judge how far the current read path in Crimson, how far is it from the classical OSD? What is missing, and what is the expected performance impact of implementing it?
Well, another way to put it is how far off do we think classic is from optimal? Or to put it another way, how far off is this implementation, even though it's missing stuff? How far is that from the hardware bound, right? So if we're close to the hardware bound, we've done our job so far. Thus, as we add stuff, we find out how much that stuff costs and whether we can mitigate it. So I don't think we actually need to find out whether it's a fair test. It doesn't have to be a fair test. We just need to find out whether it's obviously wrong.
Isn't that the classical OSD has a lot? Okay, it does a lot of checks, but in very simple case, like read over replicated backend, those checks are pretty limited. I was following the path in classical OSD, and sure, if it goes to something more complicated, the number of checks just explodes. But for simple case, it's pretty limited. Maybe the extra job we are obligated to do on main path for a simple case. No, I'm not saying about OMAPs, erasure coded pools, or that stuff. Just simple RBD case over replicated backend. Well, maybe it's not so complicated. I hope so, but.
I mean, you're right. I'm just pointing out that it isn't actually that important to be fair to classic OSD. We just need to make sure that Crimson is roughly as fast as the messenger at this point. That's what it should be. It shouldn't really be any slower than the message handling, plus SeaStor.
Well,
I guess I'm saying that an apples to apples comparison isn't actually that important. It doesn't matter. I guess it's just a matter of how much time you want to spend on it, I guess.
Okay, sounds good.
Yeah.
Yep.
Your turn.
Okay, so peering state compiles with no references to PG now, so that's good. Next step is there's some stuff that calls backend I need to clean up. Namely, I need the code that actually like gives a right to the state machine to be in the state machine, but that should be comparatively easy. So with luck, I'll be able to start testing it later this week on Classic and then push a PR. The idea here is to like use this code in Classic so that we don't have two different implementations. We'll just have one. Then there'll probably be some minor amount of effort required to fix it so it's like includable in Crimson, but that should be pretty simple. Crimson already uses OSD types.h, right? Or did we duplicate that? OSD types.h.
Yes, it is using
the header file.
This header
Okay.
file.
Good. I don't think I'm not adding anything significant over that. So that should be all right then. I did notice that we're kind of duplicating the existing OSD structure. Like there's a PG backend and a replicated backend. I don't know if this is obvious, but I wanted to point out we don't want to duplicate the structure that the OSD currently uses. It was a result of a sequence of really poor decisions, forced by decisions that had been made in the past. The PG backend, like difference in particular, that interface is really hard to use. Like it's horrible. If you go read the code, it is not helpful to understanding how PG backend interacts with primary log PG or PG. It's fine for now when we're just sort of creating like a thing to test the read path, but maybe in Barcelona we should sketch out what we think the sort of macro module structure should look like.
How would you want to split it into smaller pieces?
Well, it's not so much a smaller pieces thing, although it is also very much that. It's that PG backend, at least as it exists in primary log PG, like that interface doesn't make sense. It's just a formalization of how the code worked before that point. It's the best I could do to keep from having to duplicate.
Implementation instead of interface.
Yeah, it's the best I could do to avoid having to write the code that knows how to process log entries twice. Because there's already code that knows how to do that up in PG, but there was absolutely no way to, like the refactor I'm doing now probably is what I should have done. But I didn't. So we wound up with PG backend. So we don't want to duplicate that mistake this time.
No, that was not actually. It was not my intention. The idea to add PG backend is to abstract the I/O path into a separate class hierarchical, and to abstract out the difference between hierarchical code and yes.
Okay, that probably makes sense. But, yeah, I'm just worried about ending up with the same.
No, I'm not trying to replicate the class hierarchical in classical OSD.
Okay, cool. Oh, that's all I had. Yeah, still working on that stuff.
Okay, Yingxing, how's it going?
Okay. So last week I implemented a test tool for to compare Crimson Messenger and Async Messenger, and also send out an email of the result I have. So I think it can be a good reference to show how much performance gain we can have, at least at messenger level. So we can have the 4K 4K messages will be like 40% better, and but the larger chunk it doesn't seem the messengers the Crimson messenger is much slower in this case. So maybe why it will be some other reasons to cause the Crimson OSD to be much slower in this case. And I think this tool is very easy to use, so it can be reproduced. The data can be reproduced very easily. Okay, the second thing is I'm addressing the review from Kefu of the protocol v2. And I also want to move this perf tool to a separate PR that don't depend on the V2 implementation, so it can be used to or merged quicker.
Yeah, I don't want to hold back your V2 PR because I'm not quite familiar with V2 messenger protocol. I really want to get more help from for example from Ricardo and probably Ridok, who is more familiar with messenger.
I think V2 is currently Crimson OSD is not ready for this V2 messenger because it will just break if because the default address will be used in V2 and there's no dummy auth integrated with current OSD. So if V2 is just merged, the OSD will break, I think.
I see. So unless we ready the Monk client with V2 support, we cannot use the V2 yet.
Yeah, there are some, maybe there are some bugs. I didn't dig too deep with that.
So,
and Haichunmei, do you have something to say?
yeah. Yingxin, when I testing the Nautilus and it default used protocol V2. And so there, when I install it, when the monitor running, there are some auth bugs, and so I disable the SafeX. It seems if we do disable SafeX, it seems to works with V2.
But we VStar don't enable SafeX default by default. It is.
But I test the Nautilus without SafeX, it works with V2 protocol V2.
Sure, I mean the V2 messenger, the Crimson V2 messenger has some integration issues with current Crimson OSD.
Okay.
Mm-hmm. So I think the last thing I'm trying to figure out the corners where we can still improve the performance in the messenger. Just want to try some different implementations and see the result using the test tools.
So I just missed your test result regarding to the apple-to-apple comparison with of async messenger and Crimson OSD messenger.
Mm-hmm.
So your test result was that the Crimson that the performance of a Crimson messenger cannot on par with cannot beat that of async messenger, right? And that's why you are trying to.
No. The performance, the local test is already seems much better than async, and I need maybe someone to reproduce to verify it. Normally it's like 30% better than the async.
So Kefu, I think Yingxin and Jianpeng do two test cases. Yingxin do the client side is Crimson messenger, and the server side compared async messenger and Crimson messenger. If the client side is Crimson messenger, then Crimson client to Crimson server, we get better performance than Crimson with Crimson client with async server. So the client side is Crimson, and the server side we change between the async and Crimson. And the Crimson server will getting better performance. And the Jianpeng do the other side, another test case. The client side is async messenger. And if the client side is async messenger, it seems some case Crimson server get better performance than async server. Some case async server get better performance than Crimson server. So if the client side is async messenger, it not strongly show that Crimson messenger working better.
Do you understand?
Worse
than that. I see. So it's not a pure ring, but in most cases, if both sides is Crimson Messenger, the Crimson implementation outperform that of ASIC Messenger.
Yeah, it depends on what kind of messenger we use on the client side. So it's very weird. It doesn't make sense. So I think Yinxin do some deep dive into analysis it.
Okay, I see. Thank you.
Yeah, because for Crimson client, I can make sure it is lockless and can extend linearly because they share nothing. But with FIO, it is very, I don't quite understand the code, so it seems like a black box to me. So that's why I changed to use the just Crimson client to trigger the workload.
I see. Thank you. I think the next step is probably to just get your V2 PR merged, and so we can prepare on the Monk client side to read the V2 support.
Okay.
So I will try to working on it. Any questions, guys? Okay. Thank you, and see you next week. Bye bye.
Okay, bye bye.
Bye bye.
See you. Bye.
Yeah.